I'll give everyone a minute or two to join. So now they'll have access to join. Here.
Yeah, those kind of projects and challenges. Yeah, I'd be ashamed to deploy a bunch of those and then find out that they had 50 deployed. Oh, little undo button. It's all right.
Are they currently lead acid and you're looking to switch to lithium iron?
Yeah, there's challenges there too. So
get started here. All right. Hello. Thank you everyone for joining us today. It's Oshkosh's first webinar here. We have our panelists as well today. We'll be covering pound for pound, dollar for dollar. Is sheet metal tube better than CNC machining? We'll cover as well some key topics such as technology advancements in fabrication overall, strength and durability, as well as some different aspects of design, latest advancements, and what the future holds as well within fabrication. So it's a pleasure for me to introduce each one of our panelists here today. I'll start with you, McKay.
Awesome. Yeah, happy to be here. Yeah, I've got a number of businesses we'll be talking about today. So I own a few companies. Red Sky Technology is the primary, but we'll be showing a few of the things off that we've built over the years and had Oshkosh make for us. And just talk through some of the challenges and benefits of working machines. So excited.
Awesome. Glad for you to be here. Jacob, and introducing yourself.
Yeah, pleasure to be here. I'm kind of just a typical engineer. I worked for a couple of different companies and kind of found a niche with sheet metal that learned a lot and really enjoy. Hope I can share a little bit of that information here.
Beautiful. Thank you. And then Caleb, introducing yourself.
Yeah, so I'm CEO and co-founder of Oshkosh, and Jacob didn't say this, but he's also a co-founder of Oshkosh, and he's our VP of R&D, so he's got a lot of insight into design and technology and capability. Yeah, well, my background's actually electrical engineering, and discovered a lot of really interesting unsolved problems in sheet metal, and that was kind of the genesis of Oshkosh 6 years ago. So
beautiful. Awesome. Well, I'm glad each one of you guys are here today. We're going to go through some questions, and I'll start with you, Caleb. Give me an overview of sheet metal and tube. How do you see it stack up relative to CNC machining, injection molding, other modes of fabrication?
Yeah, so for starters, it's important to point out that CNC machining, turning, casting, 3D printing, these are all just different ways of making things. And sometimes there's only one way to make something, right? Sometimes you have to CNC machine it, put it on a 5-axis mill, or sometimes you have to turn it. And there's no getting around that. So, we cast this as sheet metal versus everything else, but actually the reality is sometimes sheet metal is right, sometimes it's not. But the case that we would like to make today is that if it's possible to do it with sheet metal, it is almost always better. And sometimes you have to get creative to make that work. But if you can do it, it's way cheaper. And we've got some examples of that too. CNC machining versus sheet metal versus casting. There's just a lot you can do with fabricated metal. It's really cool.
Awesome. Do you have anything to add to that, Jacob?
Yeah, I think I echo that basic sentiment. I won't add too much to it because I think we've got a lot of examples and things that we'll discuss throughout the course of this webinar. So
beautiful. Awesome. Okay. And then McKay, I want to start with you here on sorry. Those are yours. My bad. Let me go forward. Apologies. McKay, on your side as a business owner, going from product design, prototyping to manufacturing, can you tell me a little bit of kind of why you choose sheet metal and tube and what you're looking for there.
Yeah, I've got a few slides so I can tell some of the stories actually that tie closely in. So the one you're on right now, this is VR business. Years ago, we started the first commercial virtual reality company in the country, allowed for licensing, and there was a pretty big challenge with people trying to build out these spaces for people to participate or do virtual reality in a commercial space. And we had gone in and tried to do all sorts of solutions. And actually what ended up happening is we designed out, this is a rendering obviously of it, but we've got several hundred of these installed throughout the US. And these got designed out in sheet metal. And we were able to have Oshcut cut them. They're full wraparounds at the time. So we had to bend them by hand, some of the parts, and then Oshcut bent some of the parts. And anyway, it actually allowed for this business to put the lowest price product on the market, which gave it a massive competitive advantage. So when you're saying like from a business standpoint, what are the benefits? The easy benefit here was cost to create something that had a compelling visual that could be installed. This system, we went from having a multi-day install or where people would do build outs and hire contractors to where we could send one guy on site could install the whole thing in 1 to 2 days. And so again, Caleb mentioned the price, but it's the other side is consistency. Like price is actually somewhat secondary to consistency in a lot of ways. In my view, that one of the benefits you get with sheet metal, especially with laser cut, is the consistency is so high. Like when Oshcut delivers a piece of this product, it's the same every time. And so the process of the finishing processes are always the same. I know when the guy shows up on site, the holes are all going to line up every time, so it's not like you have to fab it every time you show up, so that means you're hiring someone, they can actually do the job instead of having multiple people go out there and have to figure out how to solve the problem. So that's a real world example. That was a big game changer for us. I mean, especially as that industry got really tight, there was a lot of businesses went out of business and some didn't. And I attribute a lot of that to the fact we were able to build a really price competitive product. Anyway, so that's one example, but I don't know. Did you want me to talk on some of the other subjects on these other slides we go through, or sure. I wasn't sure what the layout process was.
Yeah, no.
In terms of if you wanted to go through more or less, but
yeah, we can keep going if you like.
So jump back to the beginning one there, Bridger. I had one other one that was in here. So this kind of talks to
got one more back.
There you go. So this one kind of talks a little bit more to like something Caleb just mentioned as we got started, and I think hopefully this will like kick us off down the path of getting some future conversation here. And we're talking, which I know Jacob's got some cool presentations, items that are in the same realm. So we did a few years ago, one of the business I do, we do engineering, we do third party, we do investments in other groups as well. This is one of those projects. And this is actually designs for a full 3D concrete printer for houses. And we built, and this exact build was actually sitting down in a warehouse. So this entire thing is actually made of sheet metal. There's very few pieces on it that are not sheet metal that Oshcut cut. And the part that's really cool is we were able to do this whole design. It's all aluminum and it gets bent. Everything comes off of the floor here. We can assemble it and we can build this machine. Now it's the way we do the walls is a little different than all the 3D printers. So they all have their own little thing, but this machine is about 50 times cheaper to manufacture than I can go buy a 3D printer for a home, which is really something. Now, again, we have some specifics that allow us to, we engage with the walls and sizing a little bit different than a traditional house, but this thing can still print a pretty large structure. And the whole thing's made of sheet metal, which is really amazing. So, and again, the consistency, if I wanted to push play and build another unit, it's a very simple process to build another unit. All the holes are pre-cut. We didn't have you guys doing the tapping at the time. We did have to go hand tap our holes. Now that was on there, if we did another unit, the tapping would be amazing because that did suck. But tapping a little bit sucks. But yeah, so I mean, just an example. Like I think we, obviously we've talked about this and talking before and other times. It's like I think sheet metal has a scalability that's really unique. And if you think about a project from start to finish, obviously we had done other sheet metal projects before this. And so I was like, look, I know that I can get good consistent sheet metal. So let's do everything possible to build the product around sheet metal. Because everything else will be different and more complex. Like I could go buy, for example, a different rib that runs across the main frame of that structure. But then I've got to cut it, and I've got to be able to consistently index stuff onto it. And if I just instead have it designed and cut with the holes placed, like it's already going to be good. And I know the tolerances are going to be extremely high, right? And so anything we could do to put this into sheet metal was like, we know that we'll get good, consistent results. And again, the price is down too, right? But the consistency, I think, is the other part that's so massive. And that's, you know, I know we'll touch on it, but the ability to know what we're going to bend, the ability to know how that's going to come out before it actually shows up to us and know everything's manufacturable, that Oshkosh was able to say, this part, all these parts said they could be made. They all showed up exactly like we planned them to be made, and everything just fit together. This whole piece is actually all bolted. Almost everything is bolted together. There's very little welding. And so all the holes had to be done. And that's the beauty. It's like everything just fits. You go plug it all together. It's a pretty amazing process. So
that's awesome. And so why do you think, in your opinion, I mean, you're trying to design everything around sheet metal. What do you think holds, you know, other manufacturers back from doing so?
Well, so I think it's interesting because before I did kind of my first design, I don't even remember what it was. It was like the aha moment. And I know Jacob has one that he'll show in a minute, which I think is a fantastic example. But the first design that was that aha moment was like, you know, I had that realization that you could build all sorts of things with sheet metal with some bending process, and you could kind of make almost whatever you wanted. You might have to have some welding and whatever. But before then, I had never really even thought much about it. When we were doing designs, like I think 3D modeling that I'd done in the past was more of like, hey, this is assumed I'm going to put this on a CNC machine, or buy some tubing, you know, which obviously now we allow for some really cool tubing stuff. You know, Oshkosh's got tons of tubing capability now, which I've got a slide at the end for that there too. But I in my mind, I hadn't realized that when you start talking sheet metal, you really can go into 3D structures exceptionally well, but you do have to plan ahead, you know, and maybe that's a good time to show Jacob's thing. Yeah. It's like some of that planning.
Stop sharing here.
That's freaking amazing.
Jacob, if you want to show us this, I'm going to stop sharing so we can see it.
Sure. So quite a few years ago, I was working on a project and needed these motor mounts. So here's one that I picked up after the fact. They're kind of hard to come by. Specifically, this is a passenger side motor mount for a fourth generation Dodge diesel truck. And I needed two of them. It wasn't the best design because these don't come up very often, being where they're from. And I love McKay's wording with the aha moment. I actually started my kind of career as a machinist. I did a lot of machining, a lot of welding, and that was the mode that I thought in. If I was designing something, I would design it to be machined. And this could be machined. You could cut this out of a billet. It could be cast. I think that's the original production method for it. If you wanted to really get fancy with it, you could even forge it. But making just one for my use, or two actually, would have been just insanely expensive. I wasn't willing to spend a lot of money on this project. But when we were doing this was when I was very first getting into sheet metal, and I started looking at it and thinking, could this be made? And I ended up coming up with this design, which definitely fulfilled the purpose that I need. And, you know, a cost comparison, if I was to billet machine the original mount, I'm not even sure what that would cost. It'd be expensive. It'd be a ton of money because it's out of steel too.
Thousands of dollars.
And it would have to be 5 axes.
Yeah.
All the angles on.
Crazy 5 axis.
Multi setup. Yep.
Yeah. And all out of steel.
I mean, it'd be cool to see
it'd be nice. But this was, you know, maybe $50 worth of materials and then a quick weld to put it all together. And, you know, that was my moment when I realized, like Caleb said in the opening and McKay has said, like, if it can be made out of sheet metal, it's almost always the best way to do it. It's the cheapest. You get great precision and tolerance, which I think is actually kind of new to the sheet metal industry. Much better tolerance.
Qualifier on that we'll hit on. Yeah, but it's way better than it used to be. We'll say that with sheet metal and plate.
Yeah, exactly. So this part was my moment. And since then, it's really interesting because, you know, starting as a machinist and designing things to be machined, there is a definite switch. Like, oh, actually, now I design to make things out of sheet metal.
And then you go to machining if you have to.
Yeah,
Right.
it's machining if you have to.
Yeah, sheet metal deep.
I've even done some where we're all stack them, where it's like we'll cut stack and then weld those stacks. You know, because it's like it's cheap. You know, that part machine is super expensive, and we've done a couple molds, press molds that we cut stacks and throw some weld beads on it, and it you know, for what it was supposed to be, amazing. And it costs like a fraction of what that part was to be CNC.
Yeah,
which
exactly.
is cool, you know.
Exactly. It's like, man, if you can figure out how to do it, then it's just going to be really easy. It's going to be really cheap. Just a fantastic manufacturing method.
So the other piece, so jump back real quick, Bridger. I have one more slide that I think is will kind of round out. I mean, some of this topic or discussion.
While I pull this up, just a reminder to the audience too, we're going to do a Q&A session at the end. Feel free to post any questions as well in the little chat feature there, and we'll make sure to address any questions that you have. We want this to be interactive and make sure to cover anything that you need there. So
Go to the next slide down that one.
yeah.
Okay, so obviously the last piece, which is I wanted to like broach really fast, that I think is powerful because I now consider it to be sheet in so many ways too, and obviously it's what we offer, which is the tube cutting, which is like this whole new dimension in my view. And I've done way less designs in these, but we're already like there's already several here examples of designs we've done for internal and client work, and it's like but it coincides so nicely to say now you have these like built-in tube structures you can do without having to piece together pieces and weld them from sheet, but it couples so beautifully with sheet where you can tab everything in. So again, coming back to like precision and consistency, you know, the coupling of tube with sheet allows to do three-dimensional structures that are so, I think they're gonna, I'm excited to think about things that will be done with it. We've got a few designs coming up that are really interesting. I mean, to go back to the first one with some of the designs we did with that printer, if Oshkosh had tube, I'd have done a bunch of tube stuff that would have helped like speed some of those pieces up and less piecing together a few of those parts. We didn't have, you know, Oshkosh didn't have it, and I didn't know I know there are some tube manufacturers, but it wasn't like easy and consistent. So I was like, I don't, you know, this is a prototype. We just need this done. But tube on some of that really would speed some of those pieces up too. So like that like rounds out this the mental process of thinking in sheet, where it's like here's a tube, here's the sheet bended, and these things all connect together and weld or bolt up. I mean, again, incredibly cheap and highly versatile and just extreme consistency. And I know you kind of mentioned that's like kind of there's a caveat with that. Like Oshkosh does consistent work. And I think that's one of the game changers for me was like seeing that you could give Oshkosh a part and they could give you a bent part that was like consistently bent, for example, at the right angle. And like within tolerance, that as long as your tolerances weren't like some ultra high precision, I mean, you had a part and it was done, and it was done the same way every time. And I know having done other fabrication and stuff, a lot of times you get stuff off a bender and it's like you get variations in the bend itself. You get, you know, it wasn't square to align with. And so you kind of got a bit of a crap show, but everything that comes out of here seems to be just like right?
Yeah, it's a function of the nice equipment that we have, but the caveat is that, so when you talk about CNC machining, it's very common to talk about, you know, tolerances to within 1/1000th of an inch. Or better. And when you look at sheet metal, we can't even get material from the mill with a thickness tolerance of plus or minus 1/1000th of an inch, right? So it is different. And then meanwhile, we promise a plus or minus 1 degree bend angle tolerance. And we usually are better than 1/2 degree, typically. But I mean, compared to what you get out of a CNC machine, especially if there's a long flange at the end of that bend, you're actually off by quite a bit by the time you get up there. So, you know, we alluded to needing to design right for sheet metal. Well, and that's why, because if you understand that you're going to get maybe 1/2 degree tolerance on bend angle and you can't count on something better, there are actually ways to structure a sequence of bends that take advantage of the super high precision punch placement on our machines to get a perfect 90-degree bend after the sequence of 2 bends. And we can walk through exactly how you do that, but once you start thinking in sheet metal, it's like, this is going to be like 1/10 the cost. Can we jump onto my slide at the beginning, actually?
Yeah.
You realize this is going to be like 1/10 the cost. So here we just have a kind of a toy example, but it illustrates really perfectly the point, which is that part on the left is designed to be CNC machine. It's at a 3/16 inch thick material. And I just priced this last night online from one of the big online vendors, and it was $568 each for one of them. And at 10, you're looking at $316 a piece and no quantity discounts beyond that. So I designed an alternative part that uses sheet metal, and it might need to be seam welded to get strength. There's 100 different ways this could be. I brought this up and showed it to Jacob and McKay and Bridger, and immediately there are like 10 suggestions for how to make that better. So I'll defer to my betters on that one. But you can see the point here, $60 from Oshkosh, including setup for one of those, and we could turn around in a day. Meanwhile, for 100, you're looking at $14 a piece, which is about 1/20th the price. Compared to having that hogged out of bill of steel. But you have to understand what the constraints are. So there's a lot of different ways to build it. So you get thinking in sheet metal, and you almost always want to do everything you possibly can to design it in a way that it doesn't matter if your bend is 1/2 degree off, or it doesn't matter if the sheet thickness is, you know, 0.19 inches instead of 0.188 inches thick, because there's that limitation from the master coil from the mill.
Well, but it's like you said at the beginning too, I find that in a project, there are only usually a few components that need extreme tolerance, if any. And so much of the project is oftentimes, and this probably reflects a little bit more of what I tend to usually sell as product or design, but so much more of the product is either like aesthetic choices or decisions that are secondary critically, you know. And so when you get into any of that space, like a 1/2 degree, you know, is probably just fine in almost all of those cases. And then you've got some high tolerance things somewhere down the line that may have to be CNC. So the goal is like, not just like you're saying, you're probably still going to have to do a bit of both no matter what you're doing if you're doing anything complicated. But if you can eliminate some of the more expensive processes, to capture as much as you can. And this is where like, so I've got obviously more of a business background. Like, I mean, I didn't announce the beginning. So I've got software and engineering background. But so I do a lot of project engineering, but there's always this dilemma and battle between the engineering and sales, which is like the sales and marketing business is like, I can't afford to sell that product because it costs too much to make. You know, so you built the prototype and it's like, hey, it works, cool, everyone's excited about it. And then you're like, let's go take it to market. And you're over the price point of what you could get for the actual price point in market. And no one's taken their cut yet to sell it. And so now all of a sudden you've got to go back to the drawing board. And I've had that conversation with quite a few people. And that's actually a process that we do too, is when it gets done, then we go back and say, okay, well, we have a prototype. What can we do to reduce costs on this prototype? Because prototypes are always kind of outside the margin of like, you're super worried about costs. And that becomes like your manufacturability. And so when you do that stage, like, again, that's where, if you're thinking, what can we do in sheet? Some of those things you can't do, but if you can do everything possible, and you're going to save money, and that abrupt like collision between sales and your marketing and then manufacturing doesn't have to be so painful. But at least it heads it off earlier.
A little bit of an easier conversation.
Yeah. I mean, it's always going to be there, right? They always want to sell a product for
Your sales guy saying, hey, I can actually sell at this price and have margin left over. That's great.
Yeah.
So walk me through some of these designs that we have up on screen, McKay, if you don't mind. I mean, you talked a little bit about some of the different companies that you've helped found or create, as a serial entrepreneur here, but walk me through some of these.
Well, so the armor one here in the front, Oshcut cuts. I mean, we cut a lot of plate with you guys. One of the businesses I have is it's called Comparative Armor. It's just a body armor manufacturing group. Make a bunch of tactical gear and stuff, but all of our raw plate materials cut here at Oshcut. And then in this example, there's actually a stand. So we actually ship these out to retailers all over the country. Just these little stands they can put in, and the whole thing's cut out of tube. Just like an example, again, like as you get into the tube processes, it's an efficient way to do build. In fact, we did that design of that stand was designed around a cost component. So again, this is like the collision of business and design. So we went and iterated through a bunch of different designs. The challenge is we're giving the stand away if people buy the starter pack, right? But if they don't have a stand in their facility, they sell a fraction of the product volume. And so we need a stand. We needed somewhere to show this thing. And so we designed a stand, and the cheapest way to do this was actually through a tube structure that then gets some finishing shelves and stuff on. And so those stands were able to get down to, say they were like $100-ish for us to make, $120.
Can't even buy a piece of furniture for that much.
Oh, no,
Like,
yeah.
to say nothing of like a custom display stand. Right?
Yeah. And we have a CNC router that routes out the pieces that actually does the wood
It's
pieces
like a particle
bed.
Particle board, IKEA.
Yeah, that's exactly what, I mean, it's exactly.
That looks really good.
We do weld it all up, but, but we were able to ship those out for a price point that was feasible, right? Because it's like someone wants to buy $3,000 to $5,000 in materials to go in the retail store. Like, I can't afford to spend $800 on a stand and ship that to them, because that's it's a fifth of my total sale. And so you're going to be a year getting your money back, So, again, price sensitivity as you're thinking through it. This other one, this is actually for a security style trailer, and it holds solar panels and a bunch of stuff. And again, same challenge. How do you make something that's quick and effective and cheap? Tube is a super useful way to do it. The upper one is just an example, kind of a staircase. That's actually a staircase I'm going to be putting in my house and building a house right now. So I haven't cut it yet, but that's coming up here shortly. So we'll cut.
So we've got armor, solar stand, and custom suspended staircase for your custom house. So once you're into sheet metal, the world's your oyster.
Well, that's
everything with sheet metal and
100%. Yeah, you can do a lot. And there's tons of projects. I was going through just trying to pick a few that were kind of compelling as we talked about it. But I mean, I've cut so many random things at Oshcut over the years, and some of them, and that's the thing that I think is awesome, is even prototyping. Like, you can cut a prototype and throw it away, and it's like, okay, fine. Like, it was not super expensive. I have prototypes we've made out of CNC, and it's like an order of magnitude more expensive. And at the end of the day, most of those go in the trash effectively, or they get stacked on a shelf, which is the trash, until eventually they go in the trash. Right. And so it's like, you build up all this stuff when you're in business and you're iterating through stuff. And so even in that process, even though prototype is not like nearly as critical as production from a cost standpoint, it still adds up. If you're prototyping and iterating and it costs you tens of thousands to do a prototype, or maybe a few thousand, like, those numbers they still scale or impactful in your business. So, yeah.
Okay. Next question I had, Jake and Caleb, I was going to ask you guys just in terms of some of the trade-offs, whether it be, strength, also in terms of cost, like we've discussed a little bit here, and how it all relates to design, but really, you know, when you think of, are we giving up anything? What are the trade-offs with the various different fabrication techniques that are out there? Caleb, I'll start with you if that works.
Yeah, well, Jacob pointed out earlier when we were off camera that like metal's metal in some ways. And so if you can design it out of sheet metal, there's really not a trade-off there. If it's out of sheet metal, it's metal and you're golden. And there may be some few edge cases there. Like what are the properties of a piece of steel after it's been, you know, does it affect, like, does it work harden the metal and under certain circumstances to do certain things? But by and large, if you build a shape out of sheet metal by cutting and forming it and maybe doing some welding, you're basically about in the same position you were if you cast it or if you cut it on the mill. So there's really not a negative trade-off there. And if there is a trade-off, like maybe the weld has different properties, it's way more rigid or whatever, then you tweak the design. Maybe you use a thicker material, or maybe you combine two pieces of a fixture differently, or maybe you bolt it together instead of you weld it. But again, it goes back to just understanding what's different. It's like the, you know, advanced Legos, because now you have these different tools. And you're like, I have this base shape out of tube. So what can I do with that? All right, and I've got some sheet and I can form it in these ways. What can I do with that? How can I assemble this thing together? So you're taking this advanced Lego set enabled by these really cool modern day machines, and then applying that to solve interesting problems.
And you don't even realize how cool the machines are. Until you go back to like try to cut something with an angle grinder or hand plaster, you know, oh my gosh, this sucks. Yeah, you know, it's like the machine's just like, it's perfect. You know, you go do a manual. I was doing one, I was just welding some stuff on a random home project the other day, and I just thought like, oh, like I should have just got on and ordered a couple parts, because it was like I was just fabbing them, you know, and I just forget, you know, your drill bit doesn't start exactly where you wanted it to, and so your whole slightly, it's just like every little thing. You have a laser cut, it's just every time it's perfect. I've gotten so
like metal shavings, and like the minute you have to grind something, you make a massive mess.
Yeah.
And
do a little bit of surface damage.
You're creating a bunch of razor sharp little pieces of metal that are in your shop or in your basement or your garage, if it's like a project that we would tackle back in the day. But yeah, it is so much work to do, because metal's hard, you know, that's its big perk, right? Yeah. So this idea of taking a grinder or a cold cut saw or a friction saw or a drill by hand, goodness no, or a mag drill, like all of that is just, yeah, you can do it, but it's some work. Yeah.
And even cutting, like I've got a good bandsaw cut that I can cut metal with, but you know, I'm doing a project the other day and I needed fairly straight. They were on an angle, and we bandsaw cut some stuff, and I was like, you know, it wasn't like flat across the face. You know, again, you just get used to it.
Because the bandsaw,
the bandsaw's got a little bit of a variation. And I just realized, it's like, man, I've gotten really accustomed to like a lot of parts that show up fairly decently cut. And then you go start hand fabbing and you're like, oh man, this sucks. And so, because you're right, like metal is actually a lot harder to deal with than you think in your mind, especially if you get used to getting high precision and you don't really respect what those machines do. That's why that tube laser is wild, you know, the accuracy and precision on tube, and trying to index and deal with tube is such a nightmare. Anyway, yeah, so they're incredible machines. It's hard to overstate how cool they are.
Then let's talk a little bit in terms of Caleb, we can ask you this question. What trends do you see occurring now, and what do you see, you know, kind of foresee happening here in the future?
Oh man, how long do you have?
Yeah.
There's so much happening.
26 minutes.
So there's a lot happening on the machine front, meaning what technology is available. Like if you even look within the last 10 years, look at what has happened with equipment. We've got higher accuracy lasers pushing into higher and higher power. they're more consistent, they're more repeatable, they don't break down as often, which, oh boy, we love that. It seems like we always have a machine down for one reason or another, but it's getting better. And even now there's like 24 kilowatt lasers that can cut through like 2-inch stainless steel, which is super impressive. Or they can cut thin material, they can just mint blanks, mint flats so fast. And what all this is doing, so that technology is making it cheaper and more accessible to have precision parts made. And then if you look at the press brake front, it used to be that, I mean, way back in the day, that you had like a giant mechanical flywheel brake. And then you engage a clutch and that thing goes bam, and it smashes down in, and once it's going, it's going. And now, you know, we're about to buy another all-electric press brake with a safety system and everything. Man, back in the day, you had to tie your hands off. Like they had shops where they had pulls, and they'd like chain the operators to the pulls so they physically can't put their fingers under the machine. And that's how they did the safety, right? Because once you hit that flywheel, you know, it's going. And so now we've got these optical safety systems. It knows if your finger's in there, and it goes real slow if you say, yeah, there's something obstructing, so go anyway. It knows what it should look like often. It's looking at the profile of the part, and if it looks right, if it looks wrong, it can signal. And meanwhile, it can go down and bend and measure it as it does it so that you get a perfect bend, even if the material has a different thickness. And so you talk about repeatability, right? It's really enabled by this modern equipment that does things a lot better and faster and cheaper. And then what we've done is we've taken that and we've taken this modern equipment, and our goal is to minimize as many friction points between the customer and our people on the floor and the finished part as possible. We like to say we are all about painless metal manufacturing. So all of the constraints around bending that make it more complicated to design for, like what tooling does the shop have? Can this part be made without collisions? Is there going to be deformation because die loses contact partway through the bend? Are there cutouts that could cause distortion or shift the effective punch line? All of that stuff we put right on the front end. So if you're an engineer or a designer and you upload a part, you can actually watch it bend on our dies, the exact die punches and dies that we use on a brake. And if it's not going to work, our system will tell you. Or if it's an edge case, like, hey, there's not a lot of flange support here, so you might see some distortion, that shows up as well. And that gives you that instant feedback, right?
Which that's like such a massive, and we were talking a little bit about it before we got on, I started videoing it. It's like pushing that up the design process to when you're still in this kind of fuzzy stage of design. I don't know how many times I've been on there and like bend, no, you're just like slightly adjusting, because you can make decisions then that you know are manufacturable. Whereas otherwise you'd be like, call into a shop and maybe they figured out like they don't even know, and they've got to go try to put it in their press brake. And so like that's such a huge deal, that real-time feedback. I think from a customer side, being able to engage with that like immediately. Again, we do that right at the beginning of the design phase. Like, don't design something you can't make, you know. And I'm sure someone somewhere could probably bend us that part, right? But that means I got to go find them and figure out who, or if it's even possible, and then engage with them to go get it in a long, interesting process. And so it's like, if we can have it made, Oshka can make it, and we know it's done, it's doable. I know exactly what can be made, so make those design decisions early in the stage. And that completely enables that.
There are ways to get really creative. And I think what happens at other shops, and to their credit, is their sales team will bring in a job and it's worth, you know, $15,000, and they're like, or more, and they're like, well, we're going to figure out how to make this, right? And that's really cool. But it also costs more.
Yeah, is it going to be scalable, right?
Yeah, and all those overheads of the engineering to figure out how to bend a job and the quota and everything else, they implicitly get built into the price.
Yeah.
So for us, if you upload a little bracket and you want a little one-off, you might be able to get that for $50 from us, but not from many others. And it is because we've automated that front end. And a nice outcome of that is, you know, we're not the only shop in the world But if you design on our tools and it works on our tools, there's actually a great chance it'll work at other shops too, because we're not doing anything exotic on the design rule check. But Bridger, getting back to your question, you asked what's coming in the future. We have a software list of miles. We call it the hopes and dreams list, but we go through that thing. It's always getting reprioritized, but we've got 1,000 software projects, but in there and fairly close to the top, we have some exciting new tools on the way to expand bend capability, make our bend simulations even better, and expose more detail about how they'll actually be made and provide additional options there. And also add some additional services as well to that mix. So all that's in the pipe, it's all coming. So there's a technological trend from the equipment, and we will always be on the leading edge of that, finding the best machines. There's the software element, which allows us to streamline so many of the pain points in the purchasing and manufacturing process. And then general industry, there's a lot of other trends too that we could spend a lot of time on. I'm not sure if it's relevant to this conversation, but you know, what's happening with shop owners retiring, kind of the older blue collar workforce retiring and more tech enabled people. Like what we're doing is pretty novel. It won't be that novel for that long. I think within the next decade, you'll see 5 or 10 other companies doing just what we're doing. And that'll be really good for the industry as a whole. Because, you know, hold everybody's feet to the fire. When what we're doing today, which is so novel, becomes a commodity, then the whole industry will benefit. And then we'll find something else novel that we can use to distinguish us and make us competitive. But
well, you're getting into like the more philosophical, like the manufacturing world, just in general, like you're saying, which I, you know, we're seeing a lot more of that coming back to the US. I think that trend is going to grow massively. I mean, we try to do everything we can to manufacture everything stateside, you know, and part of that's consistency. And I was talking to a guy the other day, and he's like, you know, he's had a lot of manufacturing outside the States, but he can't get quick turn. You know, it's like a month, 2 months. If a batch is screwed up, he doesn't know until they show up and they're all screwed up. And you got massive inventory concerns. You know, inventory is a brutal beast for product companies. And so one of the things that, you know, I mean, we do this with our blades that Oshkosh offers, which I think is, again, like we were talking, what's really industry trend that I think is powerful. It's like the ability to do rapid turn is a big deal. Like, yeah, you pay a little bit more for it, but if you can get product, that helps hold against inventory, right? I don't have to have 1,000 units per part if I'm not selling that kind of volume because it takes 3 months to get them, right? Like I could put an order in for Oshkosh, and we did this with the VR, right? We didn't hold, when we were doing lots of the VR setups, I didn't hold tons of VR inventory, right? We would put a production timeline together for those. Oshkosh, we knew Oshkosh could cut them inside of a week for us almost every time. And so that became our standard. Like, all right, it's going to take them this long to cut it. It's going to take us this long to post process and then package and ship. And so I think, you know, like you're getting at, the industry trend is like, if we want to see, again, more manufacturing here in the States, I think it's got to be enabled through automation, right? And then, and being able to, again, have this autonomy and this quick turn so that companies can say, yeah, it's worth making it here, even though it costs me a few dollars more to build it here. There's a whole bunch of upsides on the other side of this from a business side. And so I think that's also a powerful thing that Oshkosh's enabled.
yeah, you talk about lead times. I mean, it's still common in the fabrication world to see lead times on the order 4 to 6 weeks.
Yeah.
And I was talking to another shop owner just the other day, and he told me that's their lead time, and it actually blew my mind because we've been doing this for 6 years, and long enough that it just feels normal that you got to be fast. And but depending on the industry vertical and the size and weight of parts and a bunch of other factors, actually, some people are doing business that way still. And I think that will change too when you talk about future trends. But when it comes to holding inventory, you know, if you can't bank on getting laser cut blanks or bent parts or even tube fairly quickly, then your option is, if you want to be responsive to customers, you've got to make it and stock it. And there's a real time value of money that's actually legitimate, because when you tie up capital and inventory, number one, it's not there for to use if there's a problem. Number two, it's cash tied up in inventory and it suffers from like it can't be reinvested. And yeah, and then there's inflation concerns as well. So there is actually an actual monetary value of time. And that's one of the big lean principles is you want to shave that time period off. From the moment you incur a cost to make inventory, you want to convert that into cash as fast as possible. And all these technologies allow us to help customers do that.
Yeah.
So real quick, we have a couple questions from the audience, two of which I want to hit on. What services, talking about this, Caleb and Jacob, what services will Oshkosh expand into? I mean, you're talking about the tech side, but just from a pure service standpoint.
Okay, so we've got hardware insertion coming soon. We are starting to pilot welding jobs. It's actually hard to auto quote welding for a bunch of reasons, but we're building out the infrastructure so that we can provide custom quotes for weldments. And we've actually got a job in process, right? Fairly big job in process right now that requires a bunch of welding. So we will be expanding into welding so we can get cut closer to a finished product. We are also working on ship from stock systems. So you'll be able to work with us to pre-configure a part and we can actually hold the inventory for you and then ship it same day without having to pay a rush out, for example. So that's in the queue. I could go on and on. There's so many. But that's on the
tube bending eventually.
Yeah, we're hoping for
that's actually is another question from the audience is does Oshkosh have any plans to do tube bending?
As soon as you start cutting tube, that's the first question. How do I bend this stuff?
Yeah, I actually I've been working with a company that's got a really nice tube bender and been playing around with it. And the takeaway from it is to achieve high degrees of precision on tube bending is really, really complicated. So
that boils down to you have to bend a piece just to see how it's off and then punch in corrections and then you can keep bending. Yeah. And it changes depending on the stock. The wall thickness, I mean, the tube is made out of sheet metal. So the wall thickness can vary, the radius can vary depending on which mill made it. Depending on where the weld seam is on the material, it'll bend differently. So more or less, you got to take a heat from the mill and dial it in, and then you can bend it accurately, right? Which makes it really hard to do a one-off quoted on a website, which is kind of our MO. So, which isn't to say we're not going to do it. I think there's a lot of demand for it, but there's some real engineering to figure out how to do that consistently and well with a CNC tube bender.
I know originally when Oshkosh launched the tube process itself, it was a pretty good engineering lift, right? To even enable that. And I mean, even like designing, we talked about this before, but like designing for tube bending, it's not like there's not even a consistent good designing process to where you can say, hey, this is manufacturable easily, you know? So yeah, I can see those challenges. I think that's why it's the greatest thing if we can solve it, because if you guys can figure out how to tube bend consistently.
If you solve the hard problems, yeah.
Because then you just, I mean, again, that's why I think, again, that's the message of the whole thing of why sheet metal all of a sudden is this magical thing, is you plug in something on a website and then that part just shows up to you. And it's also cheap, you know? And so it's like tube, cut, bent, same kind of thing. I mean, but like you're getting at it, there's so many complex problems in the background. But that's why it's like a design engineer or whatever, if you can just get that thing to show up magically. Because otherwise, if I'm bending tube, I got the same problems.
Maybe the solution is every time we get a heat in of stuff that we think we might bend, chop a piece off, bend it, measure it, store that for the heat, and then we can auto apply the corrections for everything we cut.
That is one of the methods that they use. There's a little bit of nuance to that because the bend corrections are not very linear for tube.
Meaning if you have a 45-degree bend versus a 90, it totally changes.
Yeah, it's not nearly as linear as it is with sheet metal, which is
Is it predictably nonlinear though? Like It's,
I can't say whether I know or not, but the manufacturer of the machine didn't seem to think so.
okay.
Seems like it would be, but they are not
The
taking
installer
advantage.
representing the manufacturer.
He didn't want to promise anything.
Yeah, it'll be difficult, but I think, I mean, it's so useful. I think there's no way that we don't figure out some way to do it.
So they were asking the timeline, so it's TBD at this point, I would say, but definitely something that would be.
Yeah, I mean, you can see how excited we get at maybe how to solve the problems, and we'll get there. I can't give you a timeline, but our MO is to expand into new services gradually as we're certain that we can provide superior value. And if we can't provide superior value, then we just won't do it. And some of these challenges are really tricky to solve. It looks like we have another question, sorry, Bridger, about logistics costs. I don't know if you were going to address that.
It was,
But shipping, especially big heavy tube, can be really expensive. So opening additional locations is one way around that, and we do have future plans to do that, to have better proximity to our customers. Another thing that we're working on literally this week, it's next in the queue, I'm going to be giving it attention as well, is to fine tune and dial in our freight and parcel quoting systems, especially when it comes to estimating sizes for collections of bent parts. 3D nesting of bent parts automatically to figure out a package size is actually extraordinarily difficult. In the computer science world, it would be called NP hard. And what it actually means is if you tried to explore every possibility, the universe would burn out before you finished.
So make assumptions.
You have to make assumptions and use heuristics. So anyway, long story short, if you see a freight price that you think is just bonkers, definitely send us an email because we can manually quote freight. But we hope to have fixed that problem hopefully by the end of next week. So you might see better results coming up soon.
Great.
That's a good timeline.
Yeah. That's good.
That's kind of software
balance
project.
the timelines.
And now that I
we don't
said it,
know.
we have to do it.
So it's official. The software team's gonna love it.
Yep.
And then another question we have is, do you plan on offering design consultation services for newbies so they can take full advantage of sheet metal techniques and avoid missteps?
So nothing specific on the radar for that yet, but what I would absolutely recommend is that you look at something like Fusion 360, which is cheap for businesses and free for hobbyists, and take that and learn how to design for sheet metal, and then upload those parts into our system, and it will tell you if it's going to be bendable or not. The best school is to try, and it costs you nothing but time to try. And it will give you so much context and experience to look at a punch and a part and a die and see how it bends, see how it forms. Tinker with that a little bit, and you'll probably know more than 99% of the engineers out there who haven't done sheet metal. You know, you can go get an engineering degree and still not understand how to design for sheet metal.
Oh, yeah. Years ago, I had an engineer that was out of college. He was a smart guy, but
yeah, they just
hadn't done any manufacturing experience, and it's like the best way to do it is hands off. Like you have to go get the experience, you know.
Yeah,
I think that's one of the big things with this too. I think one of the huge downsides to sheet metal in the not distant past was the accessibility. Designing for sheet metal can be quite difficult, especially when you factor in bending and the limitations of the machines that are going to bend it.
yeah. What tooling does the shop down the street have? You know?
Yeah, and what radius are they going to produce on the part? I have a buddy that reached out to a shop and they asked him what radius it was going to be, and it was just like, well, I mean,
It's a function of your tools and your
like, yeah, I don't know, like, so I think the level of difficulty with that in the recent past has been really high. And I think that's something that Oshkosh has done an exceptionally good job of doing, is increasing the accessibility to anybody. And it gives you the opportunity to be able to play with designs and work through things and figure things out. So maybe less on the direct help with working one-on-one with someone, but the amount of information available with the DFM checks and things on just directly available online is already massively moving in that direction.
Yeah.
Yes.
Yeah, and I think from a newbie side, if you're just getting started, like, you can think in 2D for sheet metal too. I've done a bunch of designs where I take Illustrator files and cut them. So get experience with 3D. If it's overwhelming, start in 2D. That's one of the beauties of sheet metal. You can put a line, design a part in 2D, put a line down it, go into Oshkosh systems and bend it. Right, which is really pretty novel, honestly. And so if it's hard to wrap your head around that, and I know like Fusion has a fine bending system, but it's also super clunky for the first while of using it. It feels like it's overwhelming to learn it. I think if you're starting out, start in some 2D stuff, figure out how to think about the design processes and then work your way into 3D as you go. So
yeah, I mean, to be perfectly honest, I've had 5 or 6 years of doing a lot of sheet metal design now. And to this day, I'll design something and I'm not certain if it can be made or not. But it's really easy to just go ahead and upload it and find out.
you can model anything.
Yeah. Yeah, model anything and then find out if it can be made. You don't even have to order it. So hugely useful. I use that for every design I ever make. Still,
Yeah,
to this day.
we see this occasionally. We have people who have been uploading parts for years. And come to find out, like we're talking to a shop down the street, about an hour away actually, but here in Utah, and they confided, yeah, we actually use your system to find out if we can make parts. So they get a quote request from a customer, they upload it on our platform, and they're like, okay, Oshkosh can make it, we can make it.
Yeah, we should be good to go.
And then they'll use our price as a sanity check, like, okay, yeah. It's kind of funny.
That's a super fascinating thing though too, because I've done that where you work with a client, I'm doing work for a client, we're doing design work, and I'm like, well, what is it going to cost? Like, well, let me do a quick rough design on Oshkosh, and that's going to give you the ballpark, right? That's a quick way to go get a ballpark pricing. So it's like, hey, this is going to be your threshold price, like this range. That's a powerful tool of being able to use Oshkosh to threshold stuff and then come back and dial in the details. But that's hilarious that they just said, hey, we're using it like that. Awesome.
It's more than one shop.
There's
one down in Texas.
There's
one further north in Utah. Yeah, there's a few. Yeah, pretty fun.
All right.
Yeah.
Well, that's all the questions I had and all the questions the audience had. Anything else you guys wanted to cover before we adjourn?
No, but if you have any additional questions or things you would like to cover in future webinar series, definitely, shoot Bridger an email, or you can email us just at support@oshcut.com and it'll get to the right place. And feel free to give the office a call too. It's something we can help with. So if you have any questions or concerns or whatever. So
Perfect. Well, thanks to each one of you guys for your time today, and thanks especially to the audience for joining us. As a reminder, we'll be shooting this out. A recording will be available, so you can watch it on your own accord, share it if you like, and look forward to our next conversation. Thank you. Take care.